Hello everyone, this is Andrés from VARANORMAL. Welcome to another episode where I want to let you participate on my ongoing research with the principles around the InClip microphone. I showed you already a lot of about the working principles of the InClip microphone and the results you can obtain with it. And now I'm going a step further. As you know, and as I already explained, the InClip microphone works in a way that it generates a dynamic control signal from the audio signal itself. It means the dynamic in the signal the microphone is recording is used to switch on and off the signal itself. So it's some kind of self-control. The more dynamic in the signal is, the more you have those switch on and switch off states, which is causing a kind of or let's say a suitable environment for PK modulation to occur. So the results are very encouraging, but I thought a week ago about what it would be like if I would separate these, let's say, control function that's steering this on and off of the or the switching through of the audio signal from the signal itself. And the idea was to create some kind of random noise generator with a very slow curvature, with a slow signal, and to use the dynamic of this signal to switch the audio signal on and off. So this means a separation between the control signal and the recorded signal. And I made a device, but just a prototype, a breadboard prototype, and I want to show you some results I gained with it. They're quite encouraging.
So let me quickly explain you this breadboard setup here. Mainly I have a random signal generator that generates a very nice random signal from a phototransistor that is illuminated by a LED, constant light flow from an LED. The signal is amplified and filtered so that only the low frequency signal parts are making it through. And then it goes to something like an impulse former, a stage that makes rather sharp impulses of this slow signal. Yes, and here we have a simple condenser electret microphone with a preamplifier and a stage with something like a voltage controlled amplifier. It means that the amplification the stage is controlled by the impulses we are generating here from the random generator, so that the amplification is going up and down in the rhythm of this random signal here. This is causing this modulation I told you about. So here you can see on the scope the signal coming from this slow random noise generator. You see it's a little bit clipped. The signal is very strong. And you can see it's rather slow. It's a slow signal. Now this diagram here shows the signal behind the impulse former. This is a stage that makes rather sharp impulses from those slow signal curvature you just have seen. And by turning a potentiometer, I can adjust this a little bit. So now it's almost gone, and now it comes slowly up. This would be one setting that was very interesting, where the signals are going up and down, and when I turn the potentiometer more to the right, the signals becoming stronger. And this here, what you can see is the microphone signal that is switched on and off, or let's say going up and down in the amplification, controlled by this random signal. And all this fast impulses here are my speech. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and you can see the signal is somehow chopped into chunks with a varying pulse pause, let's say duty cycle. And this is what's causing this modulation where the PK manifestation comes
So
in.
I think you could understand the working principle behind the circuit I made and the difference between this circuit and the InClip. And now I want to show you some of the results, but only in a quick view that I gained with this device. And then we go over to the real idea behind this video. This is really fascinating. I hope you will share my fascination. Now this is all very interesting already. My usual, let's say, process is to gain some results, to draw my conclusions, and then to build a prototype from it, a device, and make further experiments with this device. And I was already on my way to do this, but then I had second thoughts and I thought, just wait a moment. This is a principle that is not, well, I'm not obliged to make this, or to cast this principle in a device. I could also make this in software. And this is a trick I want to show you now, because I implemented this principle in software. Mostly all of you know me as a hardware guy. That means I'm a hardware engineer and I'm making devices and electronics. This is what I do. What most of you don't know is that I already made a lot of software in the past. Not related to ITC, or not so much related to ITC. I had some ITC projects which were not very successful, but I was creating or programming software more or less all of my life, alongside with all my hardware projects. I did this in C and C++ and a little in Java and assembler and exotic languages like TickleTK, and also came to JavaScript. JavaScript is very interesting because it's a fully fledged language that runs inside your browser. This is very interesting because it originally was implemented in those browser engines to bring some dynamic in the presentation of a website. Let's say some blinking, bleeping gadgets, some animation stuff, something like that. But it's a fully fledged language that can do everything you can do with every other language as well. So basically JavaScript is something that you can develop and run in a browser. It's quite interesting. And years ago I stumbled across a book from a guy who programmed fractals directly in the browser with fantastic results in JavaScript. What JavaScript also can do is, let's say, managing and processing sounds. This is a feature that was not very well developed in the past because it was rather complicated, and by the time the JavaScript developers invented the web audio kit, which is some kind of extension of the JavaScript language, where you can generate and process sounds. It's a very nice idea, but it was rather complicated to program, and also the information available in the internet was rather poor. So it was some years ago, some guys who could do Java programming came together and they said we must solve this problem, and they implemented a new JavaScript library. That's a library that is running on top of the web audio kit, but makes the access and the handling of those functions much easier. And they called it the P5JS JavaScript library. There's a whole website dedicated to this JavaScript library, and it has fantastic functions around animations, gadgets, video, image manipulation, and also sound. You can generate sound. We have generators, sine wave generators, triangular shape wave generators, impulse generators. You have processing like gain, amplitude modulation, frequency modulation, reverb, convolver, all that stuff that you are normally know from an audio editor. You have in this audio library that is part of the P5JS library. So my idea was to use these functions provided by the P5JS library to implement the principles I discovered with the InClip microphone and my idea by applying an external control function to the recorded signal in an application. Of course, the advantages are obvious because I don't need to make a device anymore. A device means you have to find a casing, you have to design a PCB, you have to populate the PCB, you have to do a lot of soldering and wiring and testing and stuff. And in the end, every time you want to reproduce or to copy your device and to give it to someone, you have to double the work. And you have to put this device into a parcel and send it to someone else, and you have to fill out all the custom forms and all this stuff. It costs a ton of money and takes a lot of time until you can provide these functions that are incorporated in the device for another person. And this is very sad. But if you can implement this in software, then you just can tell someone, this is software, download it, install it, and you're off. So it's very easy. The cool thing is that the software I now programmed to implement this, let's say, InClip evolution step is nothing you need to install. You just have to follow the link in the video description and it directs you to the P5JS editor server. This is a server or let's say some cloud space they are providing for everyone who wants to do programming with P5JS, and you can write your programs there online and test them, let them run, and when they're running properly you can generate a link to it and you can share the link, and every person in the world can use this link to direct his or her browser to this let's say address from the program you generate, and can it run in the browser without any installation. It's really fantastic. And now I'm going to show you how this works.
Okay, so now let me show you how to start and operate the application. I also already have put a link here. The working name of this application is Sound Chopper, but I think I will find a more suitable name in the future. But this is how I called it now. So you follow this link and then you come to the application. The first thing you will face is this dialog window. Please click OK to enable audio functions. Just click OK because this is just a security, let's say, threshold that Google, as far as I know, implemented just to make sure that no one gets access to your audio system without being allowed to do so. So just click on OK, and then the system has access. So you can already hear some reverb in the background. Let's switch this off for now. So I can explain to you the interface. I try to keep the GUI, the graphic user interface, as small as possible so that you also can run the application in browsers with a lower resolution, or systems with a lower resolution. This just here is some explanation, some text, and contact data and copyrights, the usual stuff. You have different sections or chapters with names upon them. The first one is source setting. That means that you have here the possibility to adjust the input level of the sound source. And the sound source is a very important, not issue, but thing to mention, because you cannot change you cannot configure the different sound sources from this application here. It's not possible. This application always takes the sound source that is the main sound source in your Windows system. For example, if I open the sound settings here, and you can see the input is the microphone from my headset here. And this is exactly the sound source my application is accessing. If you want to change this, you want to change this over, for example, to the line input or to the microphone from a USB camera, something like that, then you have to do this in the system settings, not in this application here. So you can adjust the level here up and down, and you already can see this is like some kind of oscilloscope here. This is a control to see if you have some signal here on the input line. So if it's 0, you have nothing, and the more you are moving this slider to the right, the stronger the signal gets. Well, let's keep it like this here, somewhere in the middle. Then you have a randomizer. The randomizer is just a simple random generator. It generates numbers between 0 and 255. And you can specify a random threshold. That means that only the numbers that are going over this threshold are used to gate the microphone signal or the audio signal here. And you also can change the speed of this process. Yes, this is very important to adjust these random impulses to a pattern that is more or less like human speech. This is something you have just to try out. It's more or less some kind of gut feeling how to adjust those sliders here to get a signal that is really bringing good results. And because it turns out to be favorable to process the signal with reverb, I also applied this reverb section here. So you can adjust delay, decay, you can adjust the mix between the dry and the wet signal, and also the output level. These impulse trains here, you can see these are the impulse trains that are generated by this randomizer stage. And you can see, for example, when I'm leveling up the random threshold, then the impulses become more sparse. So here you can see it's working. And then you have here a lot of buttons. You can record the signal. This is a very fine feature, I think. Will be recorded as a wave file. You can start and stop recording. You also have some kind of tape counter here implemented. You also can play it back after recording, and you can save the recording. And a nice feature is this here, double recording. By clicking or enabling this checkbox here, you can record the original audio signal before this chopping stage here, or before the gating, and the resulting signal after the gating and reverb simultaneously in 2 files. And this is very easy to load both files in an audio editor and to compare them, because they are synchronized. Because the recording starts exactly at the same moment and it stops exactly at the same moment. So when you have both loaded in your audio editor, you easily can identify the points where PK modulation comes in, and you can directly compare it with the let's say unaffected signal. This is what I described in some videos ago about tracing back PK modulation from spirits. You can do this now easily by yourself. Okay, so now let's switch it on here. So now you can hear my voice, and you can see my voice is chopped. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is the effect where the PK modulation comes in, and it works very well. So let's do a simple test just to show you the principle. And what I wanted to show you is another cool setting here. You can directly experience my changed voice by clicking this checkbox here. This special, let's say, variant of the reverb module, where the feedback signal is
reversed gives interesting effects that sounds very spooky. Okay, here we go. Wah, wah. Hello. You hear this nice spooky background sound? Hey, hey, hello, 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 hello. I think this also adds up to the results of this animation. I think it's very nice. I start recording. Now you can see a recording indicator here. 1, 2, 3, 4, 5, 6, 7. This is a test. 1, 2, 3, 4, 5, 6, 7. This is a test. The quick brown fox jumps over the lady dog. So I stop this. And now when I play back, the original signal you hear here in the background is muted. It's going to fade away, and the playback signal comes in. I'll show you this now. I can record indicator. 1, 2, 3, 4, 5, 7. The test. 1, 2, 3, 4, 5, 6, 7. The test. Quick brown fox jumps over the lady. Yeah, that's it. After hitting stop button, the original signal comes through again. And now we can do save recording. And now you can see the original recording is saved at the WAV file. That means it's some kind of let's say download. Your browser is downloading the file, and it's going to be placed in the download area of your file, and then you can pick it up and load it into your wave editor like this. Let's start the wave editor and go to the download section. This is the last recording that was saved. Yeah. In case you have double recording enabled, you always get two files. Source recording is always the source signal, and PK recording is a let's say allegedly affected signal. Now we can load it, and we can play it back. Record indicator. 1, 2, 5, 7. The test. 1, 2, 3, 4, 5, 6, the test. Quick brown fox jumps over the lady. Okay. So this is the principle of working. You remember I showed you the reverb function with a special reversed feedback feature, and that it's generating very spooky hollow sounds. I extracted a part of a recording I made with a sequence of this strange sounds. I want to show you this. And it appears to me like a very slow speaking voice. And I copied this content here, and I speeded up the playback, and it sounds now like this. In German, it sounds a little bit like jetzt haben wir alle noch die Farbe. Now we all have the right color. The cool thing is that even in those sequences where you have just this hollow sound from the reversed reverb feature and not anything from my voice, there is some kind of hidden slow speaking voice behind it. That's really amazing.
Well, I really think I could show you so much more what I experienced with this application. Really fantastic. But this video already gained a length of about half an hour, and that's much too long for YouTube as far as I learned. So I want to close this video now. Just take a look at the video description. That we can find the link where you can run the software. And I would like to encourage you to just try it out and play around with all those scales and sliders and buttons and check out if there's something worthwhile for you. And in case yes, spread the good news so that everyone can use this application for doing his ITC research. And there's a second link in the video description right into the VARANORMAL forum I prepared just for this application as a community project. So I would like you to give your feedback and your results into this subforum, so we all can participate and on this work and share our results. Thank you very much, and bye.